This video shows a standard 55-gallon steel drum sitting quietly in a warehouse. From the outside, it looks completely secure, but inside, a microscopic storage mistake is quietly ticking toward a catastrophic failure. When incompatible chemicals mix inside these containers, the interaction releases energy in the form of intense heat or rapidly expanding toxic gas. This is an exothermic reaction, a process where the chemical bonds break and dump their energy into the surrounding environment, creating dangerous internal pressure. This image shows dented and splattered blue industrial drums, highlighting their physical vulnerability. When a reaction occurs inside a sealed container like this, the gas has nowhere to escape. This creates extreme drum pressurization, turning a standard storage vessel into a high-yield bomb. These disasters are the predictable result of poor logistical planning. Storing incompatible chemical classes on adjacent pallets triggers a molecular chain reaction that the warehouse floor was never designed to contain. To stop these disasters before they ignite, facilities have to understand the invisible molecular warfare happening inside these containers and master the strict regulatory matrices designed to keep them apart. Sodium hypochlorite, common industrial bleach, and an acidic descaler create a lethal combination if they mix in a shared floor drain or secondary containment basin. The acid violently lowers the pH of the bleach, the scale used to measure how acidic or basic a solution is. As the acid slams into the hypochlorite ions, it rips their molecular bonds apart, instantly spawning pure chlorine gas. Chlorine gas is heavier than air, meaning it rapidly expands and sinks, pooling in confined spaces like trenches and basements. Once inhaled, it attacks the moisture in the human respiratory system, creating hydrochloric acid directly inside the lungs. Because people use diluted versions of these liquids to clean their own kitchens, they often treat industrial-strength variants as safe. That miscalculation leads to hundreds of severe workplace hospitalizations every single year. A simple janitorial error can force a total facility evacuation or cause permanent fatalities if liquid containment rules are ignored. Solid alkali metals like sodium and potassium introduce a different kind of risk. Unlike stable powders, these materials react violently with environmental factors that most facilities take for granted. A macro view shows a jagged metallic solid right before it violently reacts to a single drop of water. Even trace amounts of ambient moisture in the air will cause these metals to instantly dissolve, producing intense heat and highly flammable hydrogen gas. When this reaction is trapped inside a sealed 55-gallon steel drum, the rapidly expanding hydrogen gas has absolutely nowhere to escape. This causes the internal pressure to spike dramatically against the steel walls. You can physically see the container failing. The thick steel walls warp and bulge outward under the strain until the structural integrity gives way, resulting in a violent lid ejection or a massive explosion. A sealed steel container cannot suppress the laws of thermodynamics. The only true defense is keeping the chemicals physically isolated from one another. The first line of defense against these reactions is the Safety Data Sheet, or SDS. The SDS is a standardized document mandated by OSHA, the Occupational Safety and Health Administration, that details the specific hazards and handling instructions for every chemical in a facility. This image shows an official SDS document. To identify fatal incompatibilities, facility managers bypass the general information and look exclusively at Section 7 for handling and storage, and Section 10, stability and reactivity. This animated diagram shows a master segregation table. Decoding the SDS data feeds directly into this grid. Safety engineers map their inventory onto this matrix, plotting hazard classes against each other to pinpoint dangerous intersections. When an X appears on that matrix, it demands strict physical segregation. Flammables and oxidizers must be stored at least 20 feet apart from one another or completely isolated by non-combustible firewalls. This image shows the complex piping and containment structures of an industrial facility. Down on the floor, secondary containment systems, like independent bun walls and spill basins, serve as the final architectural failsafe to ensure that leaking incompatible liquids never touch. Protecting a facility relies on rigorous architectural and logistical discipline. While personal gear protects the individual, the physical separation of incompatible molecules is what keeps the building standing.